This is a continuation of the Chapter 11 review with problem 16. And in problem 16 we have a regular octagon. We know that because all the sides are congruent and all the interior angles are congruent. And we have a triangle. And they give us the base and the height of the triangle, so that should be easy to find the area of. And they give us the base of the octagon. So let's get started with this. For problem 16, we know that the composite area is going to be the area of the octagon plus the area of the triangle. So to start with, let's get the area of the triangle first. That's the easiest one to get out of the way. That's 1/2 base times height. So that's 8 times 7, which gives us 28. For the area of the regular polygon, as usual, I'm going to want to write one triangle. We're going to draw one triangle as our basis triangle, and we're going to work off of that. So let's go ahead and put in our apothem here. And we know that this side length is 2. We know that this, then, is 1. And we can find out the measure of the central angle because we have 8 sides. So one central angle is 360 divided by 8, which gives us 45. So this whole angle is 45, and that gives us the measure of this angle is 22.5. And so now we have to find this apothem. So that side length is going to be, looks like we're going to use tangent, taking oats away. So tangent of 22.5 equals oats away, 1 over apothem. And when we work this out, multiply by a tan 22.5 equals 1. A equals 1 over tan 22.5, which gives us approximately 2.41, and I'm going to go ahead and store that in A. Now that I have my apothem, I know my side length is 2, so I can get my perimeter. Our area, the area of our octagon, is 1/2 pa, and that's 1/2 perimeter, which is 2 times 8. 2 times 8 times the apothem, which is going to be the value we had stored, not just 2.41. We're going to use the value that we had stored in memory there. All right, that gives us approximately 19.31. Again, I'm going to store that in some memory location. Since I'm already using A for apothem, I'm just going to store this in X. So that's going to be an X value. All right, now that I have both areas, I have the area of the triangle and the area of the octagon, I can find my composite area. Area composite equals 28 plus 19.31, and using my memory location values, I get 47.31. To reiterate one more time, notice the organization of the work. It makes it nice and neat and easy to follow, and it makes it a little difficult actually to get lost because everything's in a nice organized fashion and it's easy to trace where everything came from. So please consider the organization of your work as just as important as the actual calculations and the formulas. All right, let's move on to problem 17. in problem 17, they didn't give us any pictures at all, so we have to create our own, which isn't much of a problem because we usually draw them anyway. And they gave us that it's a regular octagon, and they give us an apothem of 6 inches, and we need to find the area. As usual, let's go ahead and draw in our triangle and our apothem. And we have an apothem of 6, and we don't know what any of these values are, so we're going to have to be finding those ourselves. Again, we need to know the central angle here so we can find that angle. We calculated it in the last problem. Let's do it again. We know that we have 8 sides, so the central angle is equal to 360 divided by the number of sides, which is 8, which gives us 45. And so each one of these angles here is half of 45, which is going to be 22.5. Since I have a 6 here, I can find this x value by using tangent, taking oats away. Tan of 22.5 equals x over 6. 6 tan 22.5 equals x, and that gives me approximately 2.49. Point should go down there, and I'm going to store that in x. All right, now that we have our x value, we should be in a position to calculate our area. We know that the area is 1/2 pa. That's 1/2 perimeter. Now our perimeter is going to be this x value times 2, which gives us a side length. So it's 2x times the number of sides, 8. Because we have 8 sides in the octagon, and 2x is one side of the octagon. So there's my perimeter, and then my apothem is 6. That should give us our result, which is, it's actually going to be an approximation, approximately 119.29. All right, fairly straightforward problem. Let's move on to problem 18. In these problems, we're being asked to describe the effect of changing the given alteration in dimension on perimeter and area. So let's get started with this. In problem 18, what we're doing is we're going from this triangle, so we have a triangle that has 5 and a 12, which gives us, this, since this is a right triangle, this is a 5, 12, 13 right triangle. And we're going to a new triangle, and we're multiplying the base by 7. So this is going to be 12, and this is going to be 5 times 7, which is 35. If we use Pythagorean theorem, 5, 12, 35 gives us a 37 for the hypotenuse here. So this is the change in the hypotenuse. Now let's calculate what the perimeter of this is. Perimeter is 12 plus 5 plus 13, which gives us 30. And the area is 1/2 base times height, which is going to be, which is also 30. Now the new perimeter here, this is going to be, perimeter is 12 plus 35 plus 37, which is 84. And the area of this guy is 1/2 base times height, which gives us 210. So here, the perimeter changes by 84 minus 30, 54 units. It's an increase of 54 units. The area changes by a factor. And to get from here to here, if we do area changes by 30 times some value equals 210, x equals 210 divided by 30, which is a factor of 7. So the area changes by a factor of 7. All right, let's move on to 19. In problem 19, we're multiplying two values. So here, we're multiplying the width by 6 and the length by 1/3. So here's the original, and we multiply the width by 6, so 5 goes to 30. 5 times 6 is 30. And the length is divided by 3, so it goes to 3. Here the perimeter is 28. Here the perimeter is 66. So our result for perimeter is that perimeter increases by 38. And for area, the area is 9 times 5 here, which is 45. The area here is 3 times 30, which is 90. And what happened is we had an effective increase in area by a factor of 2. So area increases by a factor of 2. And now let's move on to problem 20. In problem 20, we're multiplying all dimensions proportionally. So that's going to change things fairly significantly. Here we have the first one. Our perimeter is 3 plus 5 plus 3 plus 5, which is 2 times 5 plus 2 times 3. That gives us 16. Our area is simply base times height, 5 times 2, which is 10. Now we're multiplying all linear dimensions by a factor of 5. So this 5 becomes a 25, this 2 becomes a 10, and this 3 becomes a 15. So the perimeter here becomes 25 plus 25, which is 50, plus 15 and 15, which is another 30. 50 plus 30 is 80. And then the area is base 25 times 10, which gives us 250. Now if you look at what happens here, to get from 16 to 80, we're in fact multiplying by 5. Because we've multiplied all linear dimensions by 5, what we have for perimeter, 2 times 5 plus 2 times 3 is the original. And then the new one is 2 times 5 times 5 plus 2 times 3 times 5 again. And so that's 5 times the original perimeter. So 5 times the original perimeter gives us 80. Looking at the area, since the area is base times height, and we've multiplied the linear dimensions by 5, the new area becomes 5 times base times 5 times height. Well, 5 times 5 is 25 base times height. And if you notice, the factor here from 10 to 250 is 25. So the perimeter changed by a factor of 5. The area changed by a factor of 25. So we write perimeter increases by a factor of 5. Area increases by a factor of 25. And that will wrap up the Chapter 11 review. and I will talk to you in the next video.